In this video, in Chapter 7, we're going to take a look at what's known as third angle projection for a orthographic drawing. Now, the idea behind third angle projection is to try to create a series of two-dimensional pictures to represent a three-dimensional object. Now, this skill used to be a lot more important before 3D modeling software like SolidWorks came about, but it's still prevalent and very useful in dimensioning objects for size and inspection. So let's take a look at what the philosophy is behind it. You have the 3D object here in yellow, and to project, let's assume that we have a glass box around it. Okay, so for third angle projection, the object is behind the glass or inside the glass box. There's also first angle projection that's covered in the book, but I'm not going to cover that here. So what we need to do for a multi-view drawing is to try to create a front, top, and right view, usually. You can also do left, bottom, and back views. They're just different sides of the box. Now, you can see that the author has created projections of what the object's outline looks like from each of the three principal views, the front, the top, and the right. So let's first look at the front and to see what the drawing is supposed to represent. So I'm just going to hit spacebar on the keyboard, and that'll bring the view box up. And now if I take a look at the object, okay, and you can't see it too well because of the coloring, but you can see that there's an overall shape here. And if I turn this just a little bit, the outline of the multi-view projection is the outline of the object. So that's always a good place to start. All right, then you notice that you see that there's a line here. That line represents the projection of this plane right here, or this edge, however you want to look at it, onto that plane. All right. Likewise, if you looked straight on the front view, this edge is going to show up as a straight line. And finally, over here on the right, you've got a couple of special lines. Now, normally these are just straight dotted lines, but the author just used a center line. But these are just small dashed lines and are known as hidden lines. So the outer edges of a circle where the tangency would be changing in this point of view, that represents that there would be a hole. Now normally, in addition to that, you'd put a center line for the hole to represent the symmetry and also to also emphasize that it is a hole. Now I can just go into that sketch and edit it. So I'll right click, I'll edit the sketch. I could put, in fact this is probably an easier way to see it, I could just put a center line in here. It doesn't have a center, an easy thing to do this with, but I'll just freehand it in here. Okay. And that's going to be approximately the location there. Notice it's blue, but normally you would also put a center line there at the center of the hole. All right, so that's the front view projection. It has it shows a solid line anytime there's an edge on the part that you can see. And it has a hidden line anytime there's an edge or the extremity of a circle shows that's on an interior part where you couldn't see it. It shows it as a dotted line. So let's just go back to the front view here, and the dark black lines are the projection of what all the edges you would see from the front. All right, let's move over to the right plane. So first thing I'm going to do is just exit this sketch. All right, and let's go over to the right side. And let me right click, edit that sketch just so it comes out a little bit darker. And we'll look at it from the right. All right, from this side, and the author was missing this hidden line. From the right, you see the outer outline of a square, and then another line across, and then we have three hidden lines. And let's just tip this a little bit to see what's going on. All right, notice that we have a little rectangle on this first surface. That would be that surface. That is showing up as the rectangle, the small rectangle here. Now this bigger rectangle on the top is really looking at the edges of this bigger part. Okay, and lastly, you've got 3 hidden lines. Okay, 2 of them are the extremities of the circle, and then this third one would be showing, this plane or either edge of that plane, like this edge, onto this viewing plane. All right, so hidden lines are edges you can't see, but they are behind things, so we would include those as well. Sometimes on multi-view drawings, the hidden lines are left off. All right, and then finally, what this would look like from the top view, and the top view is probably sketch 10, so I will right-click, edit that. Let's go look at this from the top. All right, so the top, you have the outer outline, so that's always a good starting place when you're creating a multi-view drawing. Then the circular shape shows up, and then the last line, which is this one in the middle, is this edge right here, this vertical edge. So the top is a pretty straightforward thing. Now the idea is in a multi-view drawing is you generally don't draw it on a box like this. You have to draw it on a piece of paper. So you would generally draw the front view and then you'd flip the top. Okay, let's assume that this edge that's in blue right here is the hinge, and this back or this top would hinge up so that this top plane would be parallel with the front plane. And then likewise you'd hinge the right, okay, about the right side on this hinge point, so you would turn that one out. So all 3 views would be looking at each other, with the front being right here, the top being above it, and the right being to the right. Okay, so it's like unfolding the sides of the box, and that's shown in the book. So that's a little bit of a little introduction to what multi-view drawings are all about. They're trying to represent what a 3D object will look like when looked at from 3 different vantage points, most likely the front, the top, and the right. All right, in the next video, I'm going to show you how to actually sketch these multi-view drawings on a piece of graph paper.